This video is for 2.1.4, Document the Assembly. In this video, you will learn the different components of an assembly drawing as well as their purposes. First, let's take a look at what an assembly drawing is. An assembly drawing documents and provides instructions for how individual parts should be joined to form the final assembly. Based on the complexity of an assembly and the information that needs to be communicated, an assembly drawing can include a variety of views, as well as other drawing components, such as a parts list that fully details how parts are assembled into a larger system. This is an example of an assembly view. Over here, we have the multi-view components of the assembly, and then over here we have an exploded view. This exploded view also includes something called balloon annotations. Those balloon annotations have individual numbers and are then noted in the parts list down here. This area right here is a note indicating more information about the assembly. We'll learn more about these parts of an assembly drawing as we continue through the video. So let's first discuss the multi-view drawing component of the assembly drawing. A multi-view in an assembly drawing serves a similar purpose as it did for a single part. The assembly multi-view represents orthographic projections of an assembly and includes annotations and dimensions to communicate how the parts fit together and interface. It's important to recognize that the geometry of each part is defined separately in a part drawing, so annotations and dimensions added to an assembly multi-view only show the geometric relationships between the individual parts. So again, this is where the multi-view drawing is located. Here, you'll notice that we have a front view, and a side view, and the isometric view. There is not a top view included in this model. You may need a top view depending on what your part looks like. Now let's take a look at the exploded view. An exploded view shows how individual components fit together and provides details about the individual parts using a parts list and balloon annotations. So over here is our exploded view. You'll note that the balloon annotations have individual numbers in them. Those correlate to the parts list, which we'll talk about in a moment. So balloon annotations are used to quickly identify a part. This approach allows detailed information to be efficiently organized in a table instead of creating a messy appearance if the information were to be displayed next to each part. There are specific annotation guidelines for balloon annotations. Each balloon contains a single number within a circle, then that's connected to a component with a leader line. The balloon number corresponds to an item in a parts list. Balloons do not have horizontal or vertical leader lines, they're on an angle. Balloons are the same size and are grouped in an easy-to-read pattern. Now all of those balloon annotations lead us to the parts list. A parts list is a table with information about each part in an assembly. The single number in a balloon annotation corresponds to that parts list. A parts list can be customized to include information that's needed for the assembly, such as the item number from the balloons, the quantity of a particular part needed for the assembly, the part or drawing number as reference to the detail drawing, a description such as a part name or a complete description of a part, what the part is made of or its material, and then information about vendors or where the part comes from. Over here we see the parts list. If we compare this to the balloon annotations in the exploded view, we can see that part number 3 we have one of, and it's titled the wedge. It's also made from birch, which is a type of wood. Part number 2 is over here, and it's labeled the arch. We can tell that we also need one of them, and it's also made from birch. And our last part, part number 1, has a quantity of 1, and it's called bar_tall, and is also made from birch. So now let's talk about notes in an assembly drawing. Notes in an assembly drawing serve a similar purpose as they do for a single part drawing. Notes provide crucial information to describe the assembly geometry and the process. If we look here, we can see that this note includes all of our tolerances so that we know it's plus or minus 0.01 inches, and that we know that all the parts are adhered together with wood glue. That means that there should be a layer of wood glue in between the 3 components. And we know that these dimensions right here have a tolerance of 0.01.